Good morning students, this is Junita Mukherjee from SS Public School. Today we are going to start a new topic of this class 12 physics alternating currents. So today's topic is root mean square value of AC. So what is the root mean square value of AC? Let's see. Okay. So it is defined as that value of AC over a complete cycle which would generate same amount of heat in a given resistors, that is generated by a steady current in the same resistors and in the same time during a complete cycle. So in a complete cycle, the AC completes over a cycle and generates the same amount of heat in a given resistor, particularly in a given resistor, that is generated by steady currents in the same resistors and in the same time. So steady currents generated in the same resistance and in the same time in one complete cycle is what we call the root mean square velocity. Root mean square value of AC, not velocity. It is also called virtual value or effective value of AC. It is represented by RMS or IEFF or IV. Suppose I is the current which flows through the resistors during resistors R in time T produces heat H. So we know it very well from the 10th standard onwards. We are knowing about it. What kind of heat generation will be there because of the heat produced. Instantaneous velocity of AC I equal to I0 sin omega t, which is we have taken the instantaneous value of AC, that is alternating current. If dH is a small amount of the heat produced in the time dt in resistors R, then dH is equals to I square R dt, which is from the equation H is equals to I square RT. Okay, we have already been through in 10th standard from this equation. In complete cycle t equal to 0 or 0 tends to 0 t, the total heat produced is H. Okay, so after this integration, equation number 1, we get dH, integral dH is equals to 0 to t, 0 to 2 because the time period is from 0 to t itself. Okay, from t to 0 or 0 to t, sorry, 0 to t will be equal to I square RT, that is H value we are putting it here. So H will be equal to 0 to t I square RT. Okay, the value of I in the above equation will be equal to 0 to t I0 sin omega t, because I we have the value here I0 sin omega t, so I square it is being given. So this particularly square this particular equation. So sin square I0 sin omega t square. So what will the value of it? By integrating we will get I0 RT sin omega t dt is equals to I0, we are taking it out, and this will be equal to 1 minus cos 2 omega t by 2 dt. Okay, because sin square omega t will be 1 minus cos square omega t by 2. Okay, so we are taking it out, I0 we are taking it out, taking the 2 out, that is I0 square R upon 2, 0 to t 1 minus cos 2 omega t dt. Okay, so we are taking it out. If we are taking it out, then we will have this first equation multiplied with this particular equation in terms of 0 to t, and this also in terms of 0 to t. So we are taking integration sign of 0 to t dt is equals to 0 to t cos square omega t cos to omega t dt. So this will be equal to t raised to 0 to t sin square 2t upon 2 omega 0 to 2 itself. So this will be same. This will be different, little bit different. T minus 0 will be their limit. Okay, then we have taken 1 upon 2 sin square omega t. T will be there because first limit is there, and this will be equal to 0 because 0 is there. So 0 sin 0 is equal to 0. We know it very well. T minus 1 by 2 we have taken common, and we have taken here 2 into 2 omega, that is omega value we have taken here, that is 2 pi. 2 t is equals to 2 pi we have taken. 2 pi minus 0 is itself. Then we have t minus 1 by 2 omega, 0 minus 0, we will cancel it out and we will get the value I0 square RT upon 2. Second equation. And we know it very well, that is sin 4 pi equal to 0. Sin 4 pi is equal to 0 itself. Now if RMS is IRMS is RMS value of AC and H is the heat produced by RMS current. So IRMS is equal to H IRMS RT. IRMS square RT. This is the third equation we can take. Now we have compared the equation number 2 and third, that is equation number 2 and equation number 3. Okay, so I square RMS RT is equals to I0 square RT upon 2 is equals to I square RMS is equals to I0 square upon I square upon 2. Then we will have this equation value given by RMS I0 square by 2 is equals to I0 upon root 2, that is 0.707 I0s. Okay, so this is the value of this particular equation, and IMS is equal to 70.7% of I0. Okay, so the above equation, this particular equation, conclude that average value of the current 70.7 is the peak value of the current itself. Because up to that particular limit, we are raising that particular value from 0 to t itself. We have taken the limit, and this will be the maximum value approaching the peak value. That is the peak value of itself. This is the peak value. Now the same way, the RMS value of a that is alternating EMF will be ERMS or EFF or EV is given by ERMS is equals to E0 from root over of this C we have taken. Okay, root over of 2 we have taken. So this will be equal to what will the value? 70.7% of E0. Okay, so the difference of the I0, IAV and IRMS are shown in the figure. IRMS is the value of 0.707 I0. This is the value, middle value. This IBV will have 0.673 I0, this particular value, and I0 will have the peak value itself, that is equal to 70.7% of IE0, or you can take I0 as a whole for IRMS. So IRMS, I have told you what is that. It is the that is complete cycle value in which the current is generated in a steady current is generated in a given resistor of the same resistor and same time interval, which is given by this particular value IRMS, which is supposed and thus it has been taken because the heat generation is there in the system, and we have the complete cycle from 0 to t, and we have integrated that particular value, and we got the value as 70.7, which is the highest or the peak value of the current itself, and from that peak value we have taken the IMS R0 value and IBV also from this particular graph. So hence this particular topic is being finished, and I will looking forward for some other topic in the next video. Thank you, students.